we have done find dm and bm, leaving your answers in third form. Find the angle between the plane ACD and plane ABC. So let's start with ACD. What is that plane? Well, let's move around the diagram and see what we can find here. The mechanism is that we can just consider ourselves walking along this diagram. Zoom out a little bit. I think I'm off screen, therefore. There we go. So what we have is we need to work out A to C to D. So from A, I go to C, I go from C to D, and because it's a plane, I can go back round to A, and so ACD is this plane in here, and so that plane is ACD. The other plane is A to B to C, and so what I'm going to do, again, I'm going to use my diagram from A to B, and of course B to C, and as it is a plane, I can finish it off by going back round to A. So there's these two planes. One plane is the plane at the bottom here. The other plane is the plane on the side surface. So in these circumstances, what we need to do is we need to figure out what is the angle between between these two planes. And so one thing we could consider is if the bottom plane is that red one that I've just created, and the top plane is slightly different. The top plane, as I've just, or the side plane is this blue one that I'm going to try. Oh no, I cannot. It's not going to allow for that nonsense today. What I will do, but I do prefer the blue. Now let's continue. What I will do is I will recognize that this blue plane includes this line, dm. So here we go. So I'm going to take this blue plane and I say that it's going to include that line, dm. In fact, of course, the blue plane is, in fact, I can very quickly represent it as multiple lines so that we can better see this blue plane, arguably. So as you can see there, I'm perhaps aiding, there's a probability that I'm making things worse, but let's suggest that I am going to color that blue plane somewhat by way of very basic stripes. So there you go, there's the ACD plane, and we need to compare the angle between this ACD plane with the ABC plane. So what is that angle? That angle can be said to be the angle here, from here to here. Right, that is the angle between the plane that is blue with stripes and the red plane on the ground there, arguably. Now this angle can be worked out by getting rid of all these concepts of planes and simply saying, well, if that is the angle, why not take this triangle, the triangle DM, which we've just done some work on, DB, which we know it has a length of 4, and this triangle on the base, BM, which we've also just done some work on. And I can take that green triangle out and just work out this angle. What is it that angle is for this little triangle in here? Well, first of all, like I said, dm is root 7. So in these circumstances, I know that this length from here to here is root 7. bm, we've just got as 3 root 3. So we know that it's 3 root 3. And db, as described here, db, which is synonymous to bd, is 4. So in these circumstances, we have all the sides of the triangle. The only thing we're missing is this angle, and that will tell us the angle between the planes, some might say. Now, what I can therefore do is I can have this quick conversation with you that will lead us to the solution. I said we have the knowledge of the lengths of 3 sides and wish to find one angle from said triangle. This requires cosine rule. We can take the c squared equals a squared plus b squared. We can put this cosine rule correction in it, minus 2ab cos theta, because it's not a right angle triangle anymore for which Pythagoras is about. Instead, this is for other triangles like the one we have, which cosine rule is about. And so what we therefore do, we're going to use cosine rule. One thing to be aware of cosine rule is that the angle that is theta should be opposite the angle that is c. And this is synonymous to when doing such things as sine rule, we ended up having to consider that the lengths and angles need to be quite specifically done in order to find the correct positions that you want, as I describe in other videos, or the correct values that you want, as I've described in other videos. We can go into detail as to how the cosine rule is produced in another video, and if there is enough demand for that, I can produce that. But for now, be aware that C and theta, there's an advantage in keeping these opposite each other. So that is to say, this angle in here, which is theta, it is worth considering that this C therefore should be 4 in these circumstances. We're going to implement that concept. The C should be 4. And so what I'm going to do is I'm going to implement that. I say, okay, let's put C as 4. Angle theta we want is x. I'm implementing that as tradition. Recall that dm is root 7, so I'm going to put root 7 as this side here, and root 3 times 3 is going to be this side here. Therefore, I'm going to implement that. I say that this becomes root 7 squared plus 3 root 3 squared minus 7. Minusing the root 7 squared from both sides leaves you with 4 squared minus root 7 squared equals 3 root 3 squared minus 2ab cos x. Minusing the 3 root 3 squared on both sides again leaves you in this equation here. And thence from there, it would be advantageous to realize you want this cos x, so let's divide both sides by minus 2ab, leaving you in with this equation. And then we're nearly there. We know a and b already, we just haven't implemented it yet. A and b can be implemented as I've described in the following parts here. You can see that therefore it's root 7 and 3 root 3. Finally, this is cos x, so this is cos an angle, and I want that angle. So I'm going to do inverse cos to get it. Cos to the power minus 1, implement that, equals x. And so finally, I have the equation that allows for me to calculate x. X being cos to the power minus 1, 4 squared, minus root 7 squared, which is 7, minus 3 root 3 squared, divided by minus 2 root 7, 3 root 3. And it's advantageous to make sure that this is done correctly in the calculator, because there can be a large amount of mistakes that can occur when doing this as a result of perhaps the fiddliness, for want of a better phrase. And note that in these circumstances, the top for this should come out as negative, and therefore the negative cancel to give you a positive value of the ratio between adjacent and hypotenuse, which is what this technically represents. Regardless, what's most important is that I went through the steps, I stuck to this concept, I took it step by step, I tried not to make a mistake and took my time, and finally I got to this position where x, which is the angle, should be cos to the power minus 1, this value I'm not going to read again, which gives you 49.12 degrees to 2 decimal places or 4 significant figures, and henceforth, unless I have made a mistake, that angle there is about 50 degrees, such that the lengths fit what have been described for the problem. And thank you very much for your time.